an honor for me to deliver my inaugural lecture today in this great university of ours, the Kwame Nkrumah University of Science and Technology, the world's best university in quality education per Sustainable Development Goal 4. The Almighty God has been gracious to me throughout my journey. I am so grateful to God for how far He has brought me. Thank you, Lord. It is indeed a great pleasure that several former and current colleagues, mentors, advisors, friends, and family have come far away from Ho, Qatar, Dagbani, Accra, Cape Coast, and other places to be guests at this lecture. As a climate scientist, it is no surprise that one of my favorite verses from the Holy Bible resonates with the element of nature, and I quote, "The cloud poured down water, the heavens resounded with thunder, your arrows flashed back and forth, your thunder was heard in the wild wind, your lightning lit up the world, the earth trembled and quaked," unquote. Prof. Chair, these scriptures shows the tremendous power of God and thunder and lightning. Have you been hit by lightning before? I have witnessed it. Prof. Chair, as a young boy walking home from school, one day, a sudden heavy storm broke out. This prompted my friends and I to seek shelter at a nearby supermarket. Suddenly, a bus pulled out and a passenger stepped off. In a tragic turn of events, he was struck dead by lightning. I, a few meters away from the scene, was profoundly struck, deeply touched. The scene and the mysticism surrounding such events kept flashing through my mind till today. Prof. Chair, the memory of such events has influenced my life quest to crack the climate change code. And I hope that within the lecture, I will explain the concept on lightning. In this lecture, I will take you through my motivation for embarking on the memorable journey, cracking the climate change code, its impact on Sub-Saharan Africa, the future of the revolution, and the role each and every one of us had to play. The transformative experience from the lightning strike influenced my journey, starting with BSc Physics, which laid the foundation of my understanding of the physical processes and the natural world. Then I further specialized with an MPhil in theoretical physics, diving deeper into the complexities of our universe. My thirst for further knowledge led me to a PhD in atmospheric and climate science, bringing me closer to comprehending the weather events I witnessed. Prof. Chair, as part of my PhD study, I took a one-year course in environmental physics. As part of this course, I took a course in ocean dynamics and circulation. A component of the course was to embark on a field measurement campaign on the ocean. The trip was named Poseidon 92, being the 92nd trip of the ship Poseidon. Here I was, a young man from small town, Dagbani in the Volta region, from Ghana, on a big ship Poseidon in the middle of the North Sea, dropping expensive equipment, as you can see, up to the 5 kilometers in the ocean to measure things that will benefit humanity. A spectacular 3 weeks adventure where we measured ocean depth, pressure, temperature, salinity, which are essential parameters to determine the ocean current and transport. The experience on the trip allowed me to advance my knowledge base across all areas of the climate system: the land, the atmosphere, and the ocean. Prof. Chair, permit me to briefly present my PhD research that prepared me towards cracking the climate change code in sub-Saharan Africa. My PhD work was a contribution to ozone hole science. The ozone hole is a term used in the climate community to represent very low concentration of ozone in a polar region. As you can see, the area which is violet, that is very low concentration. That is where the term comes from, hole. So then that shows as a whole. So that is how the climate community came by the word ozone hole. Now, what is the cause of this? The cause of ozone hole is because ozone reacts with the halogen compounds and other related compounds. Now, why do we have to care about ozone? Ozone layer is vital in the stratosphere because it protects us from harmful UV radiation. What was novel about this work was that this was the first time nitrogen dioxide, a nitric radical, was retrieved from the lunar occultation satellite measurements. The result of this work improved our understanding of nighttime nitrogen oxides behavior in the stratosphere. Here, you find me enjoying the usual German tradition after successfully defending my PhD. I am shown here seated on a kite as my supervisor pushed me around the entire building, our institute building. The cover page of this book titled Stratospheric Ozone, Nitrogen, and Nitric Radical Number Density Profile from Schematic Lunar Occultation Spectroscopic Measurement, Retrieval, Validation, and Interpretation, published from this thesis, is what you've seen in aside. My check on this book, currently at Amazon, costs $114. What then is cracking the climate change code? At the very core of the impending climate change lies an intricate interplay between natural, social, culture, and climate system that shape our world. Unveiling the complexity of these interplay is what I refer to as cracking the climate change code. My life work as atmospheric climate scientist has been dedicated to unraveling the climate change code in sub-Saharan Africa. Today, I am proud to walk you through how my work and its findings have contributed to cracking the climate change code in sub-Saharan Africa. Ladies and gentlemen, I would like to present my motivation for cracking the climate change code in sub-Saharan Africa. Sub-Saharan Africa is a region that covers 46 countries and has approximately 800 million people, and is rich in cultural diversity with over 2,000 languages and varying traditional practices. It is home of some of the world's most iconic wildlife. Its diverse climate includes arid, semi-arid, desert, tropical rainforest with mixed savanna, mountains, and coast. The region is highly vulnerable to climate change and has a limited environmental and socioeconomic capacity. On the average, it is projected that over 71 million people in sub-Saharan Africa will become climate refugees. Ladies and gentlemen, these figures are alarming. As an atmospheric climate scientist living in sub-Saharan Africa, I was aware of the danger of becoming climate refugee. More so, I was aware of how much work was needed to unveil the climate change code in sub-Saharan Africa. Allow me to explain the term climate refugee as I mentioned. Prof. Chair, ladies and gentlemen, imagine being at your home during rainstorm. It gets flooded and you are now forced to leave due to flood waters in your room and you have no place to sleep. Oh, son of man, no place to lay your head. Nadmo became the good Samaritan, decided to rescue you, providing you a shelter for you and your family in a church hall. You can imagine a church hall. You leave your queen-side bed and you now have to sleep in a student mattress. Are you not a climate refugee? Okay. Climate change poses risks to Sub-Saharan ecosystem, and these are real. We see presently rising temperatures, changing rainfall pattern, extreme weather events such as heavy storms leading to flood, sea level rise, heat waves, and droughts. Some of these events are driving rural-urban migration, as shown in the diagram on the slide. You see in Ghana, we usually have the drift from the north to the south, and the places that they get to in Accra, Kumasi, Takoradi, among others. From 1955 to date, this trend continues, and we see exponential increase in the urban population. This is the norm of the rest of Sub-Saharan Africa. For example, in May to June this year, we have extremely unstable weather. Just to mention that this year in climate community, we call it, this is an El Nino year. This year is an El Nino year, so we expect a lot of extreme events. That is why you even saw some raining yesterday. It's not that we don't call it climate change, that's a variability. So these are things that we see that happening, that's part of El Nino year. And this happened to say that about 280 people were rescued from flood in Ashanti region alone this year. Today, this is the common experience in Ghana and the rest of Sub-Saharan Africa in the rainy season. The slides show community displaced, injured, some injured, even death caused by flood. This occurrence has increased drought throughout the country in the last 5 years. As you can see on the plot, the last 5 years seem to show that exceptional increase, and we expect this to increase in the future. Ladies and gentlemen, our collective well-being depends on a sound knowledge of the climate system. Unveiling the connection between the climate system and society is achievable through cracking the climate change code. Therefore, critical research in climate science is essential to inform policy interventions to safeguard our world. I have intentionally ensured that my work extends beyond borders, as the impact of climate change knows no boundary. Prof. Chair, I would like to share with you some of the research that I have engaged that contribute to climate change impact, starting with malaria control. Malaria remains a major health problem and a substantial cause of mortality in Ghana and Sub-Saharan Africa. It is an infectious disease transmitted to humans through the bites of infected female Anopheles mosquitoes. It is life-threatening. For instance, over 90% of the global malaria cases and deaths in 2020 occurred in Sub-Saharan Africa. Children under 5, pregnant women, and the poorest community are the most vulnerable. Many hospital admissions are due to malaria, stressing Ghana's fragile health system. Prof. Chair, malaria is climate-driven. For instance, temperature below 16 degrees and above 40 are not favorable for mosquito larvae development and also survival of the adults, respectively. Rainfall provides larval habitats for mosquito breeding. Relative humidity of less than 60% support mosquito survival. A steady wind is favorable for mosquito movement. All these conditions mentioned are prevailing in Sub-Saharan Africa. In order to provide efficient tools to support policy intervention in malaria control, a malaria model was developed called VETRI. The model is a computing framework of malaria early detection, early warning, and response. Prof. Chair, I am proud to say that we contributed to the models by developing the hydrological and temperature scheme shown on the yellow section of the model framework that is being shown on this. Also, we contributed to the validation of the model by using hospital data. We collaborated with our colleagues from the College of Health to do this. Prof. Chair, the VETRI model has its origin from Italy, with contribution from my team in KNUST, and also from other colleagues from University of Liverpool, UK, and University of Cologne, Germany. These illustrate the depth of my international research collaboration. Our forecasting solution is new and an improved way to track malaria trends. It does this in a real time and as shown with a resolution of 5 kilometers. Ladies and gentlemen, I would like to show a country-wide malaria case forecast from veterinary. As shown, malaria transmission is generally all year round in the southern part of the country and seasonal in the northern part of the country. On this slide, you will see that the blue-colored areas represent very low cases, and yellow-colored areas represent moderate cases, and red-colored areas represent high cases. Also, we observe that areas above altitude of 600 meters have very low malaria cases. Ladies and gentlemen, I want to ask, where in Ghana will be safe then for you to live if you don't want to have malaria? Yeah, our work has shown that the good example of place to live if you want to avoid malaria is Abetifi in the Kwewu Mountains and Amejokwe in the Volta region. That was what our study showed us. So if you don't want to have malaria, go and live at these places. Most importantly, our tools guide decision makers on where to best use resources like mosquito nets, testing kits, and medicine. With our accurate information about where malaria is most prevalent, targeted policy intervention can be achieved. The veterinary model is currently being used in several countries within Sub-Saharan Africa and beyond to predict malaria transmission, as shown in the map. A demonstration of the veterinary model is currently on display at my exhibition in the foyer outside the Great Hall. When you go, the screen, the right screen is showing the veterinary model. And we're also looking at even prediction up to what will happen in the next 50 years and so on and so forth. We are looking at it. We were able to make this impact through QUESI project, that's quantifying weather and climate impact on health in developing countries, where I served as the project climate scientist. I would like to highlight human-induced climate change. Prof. Chair, there is overwhelming scientific evidence showing that human activities, particularly burning of fossil fuel for energy, deforestation, agriculture, are primary contributors to increasing global surface temperature. This is due to increasing greenhouse gases such as carbon dioxide, methane, and nitrous oxide. Here, I would like to show evidence of human-induced climate change. A critical look at the graph, Prof. Chair, shows, unlike the prehistorical observation, most recent years have seen exacerbation in global surface temperature, and it is strongly human-driven, as indicated by the relationship between the red line, that is which is anthropogenic force in human-driven, and then the black line, global surface temperature. Moreover, rapid economic growth, population expansion, and urbanization in Sub-Saharan Africa have placed immense pressure on natural resources and intensified human-induced emission in the region, which is projected to triple by 2050. This is expected to increase greenhouse gas effects contributing to global warming and amplifying climate change indicators. Prof. Chair, allow me to draw your mind to what is happening at our own doorstep, Owabi. Owabi watershed is widely known for its ecological significance and water supply. The watershed that contains the dam serves as one of the sources of water for residents of the Ashanti region. The watershed faces the detrimental consequences of rapid land degradation and deforestation. The increase in sediment loads have deteriorated the water quality and therefore increased costs of processing water. The satellite image presented in this slide here are the results of our research, demonstrating that there's a human-induced impact on this watershed. The reddish-colored area on the map are indication of human settlements that have expanded from 1986. As you can see, 86 is where we see a lot of greens up to date. Now, 2023 image shows a massive encroachment on the watershed, and these strongly highlight the role humans play in climate change. Prof. Chair, it is imperative, therefore, to enforce laws on deforestation, ensuring sustainable land management practices, and encouraging afforestation effort at the watershed. Restoring the Owabi water ecosystem will enhance its resilience and capacity to regulate water resources effectively. Additionally, evidence of human-induced climate change is shown on the slide for urban flooding. For example, in June 2018, over 1,000 persons were displaced. 450 communities were affected. 210 deaths were recorded due to flooding in Ashanti region alone. Prof. Chair, ladies and gentlemen, given the illustration, human-induced impact of climate change on society, a critical step in cracking the climate change is data. Data is the key. Now, data based on the field observation from the dynamic aerosol chemistry cloud interaction in Africa, DASIWA project, is presented in this slide. DASIWA, a regional and European partnership, deepens our understanding of atmospheric processes, improved the prediction of numerical weather models, and validation of satellite data across Africa. It's deployed 3 research aircrafts based in Togo that monitors emission over the Guinea coast of West Africa. When you go out, there's a poster showing that the route of this aircraft. Additionally, it deploys extensive ground-based instruments across Ghana. And these instruments, apart from Ghana, we see the same instrument Benin. Similar, we have Ivory Coast and Nigeria. However, Ghana serves as the main super site. Also, we had about 17 rain gauges that were installed across Ashanti region. This project collected the most comprehensive atmospheric data set for our region to date. I am proud to announce that I led and won the bid to host the super site in KNUST. And DASIWA attracted over 2 million euros of funding for KNUST super site alone, and where I served as the lead climate scientist. Prof. Chair, I would like to explain the concept of lighting incident that I witnessed as a teenager, that which has led me to take this path of journey. Now, lightning and thunder are found in rain-bearing clouds. These clouds, we call them the cumulonimbus clouds. As the cloud grows, positive and negative electrical charges begin to build up within it. When the difference between the positive and negative charges gets too large, Mother Nature steps in to balance the books through a surge of electricity flash that we are calling lightning, which neutralizes the charges in the cloud. The different direction taken by this lightning flash creates a temporal vacuum or an empty space, which is quickly filled by a surrounding air. As this air collapses into the vacuum, we hear a loud accompanying sound, which we call thunder. The lightning flash contains which is the danger part of the issue, the lightning part contains about 100 million volts of electricity. far more than which a high tension line can carry. Flowing at a speed of light, because it's electromagnetic wave. So it's flow at the speed of light, 3 times 10 to the power 8 meters per second. So this is the issue. It's traveling that fast. So this can strike objects on its track within a blink of an eye. Prof. Chair, as shown on this slide, is the monthly lightning climatology for West Africa. What is notable here is that we have been able to forecast the frequency of storms associated with lightning across West Africa. This allows us to make lightning forecasts for various cities and towns throughout the sub-region. Our work has shown that, for example, for Kumasi, lightning and accompanying thunder are frequent during the onset of the rain. That is March, April, May. And also at the later part of the rain, September, November, October, November. So watch out around this time for lightning, and soon I will explain. Now let us imagine that this whole building that we are living in is not lightning protected. That is, it has no lightning arrestor. And then the lightning decides to hit this building. What will happen? We don't know what will happen. I'm saying this because I want to emphasize that all our buildings should be protected. You should make sure that whilst you are putting out all buildings, lightning arresters are very, very, very important, and you should not give room. The other thing I also want to say here is that whilst you move around, it is not safe standing on very tall buildings or tall trees. People think that when the trees are tall, they are likely to track the lighting, yes, but it's not safe because you can imagine the volume of voltage of electricity that can hit that tree, and you standing under can be affected. So never stand under any tall tree as a means to take shelter. Go around buildings which are likely protected. So this reminds me that possibly my building where I was staying under the supermarket was lightning protected. And so as a young boy, 13 years, I was saved. Weather information is relevant for our outdoor activities, including farming, fishing. Without it, we are all at risk, especially with the effect of climate variability and change. Prof. Chair, allow me to share a story about how I provided impact-based climate information in Ghana. It all started when I was contacted by an insurance company that wanted to insure farmers in the northern part of the country. They were interested in knowing how climate patterns will affect agricultural productivity for the farmers and that they are insuring. The question came, and then I think through. I thought I can find solution in literature. I went there, I said, oh God, then I said, I have to work. I set out with my team to provide seasonal forecast information by computing rainfall onset, cessation, and the length of the rainy season, including the expected variability due to climate change. I computed the onset using the rainfall amount, and I decided to again change my method, try what will happen if I use the rainy days. And then I have shown that you can use both. You can use rainfall amount or the rainy days, and you get the same results. While the insurance company only wanted this information for a section of the country, I expanded it to cover the entire country and publish it. This is my most cited publication, as this work has implication beyond agriculture industry and is relevant for other sectors of the economy like tourism, health, aviation, transport, sports, construction industry, among others. I have also partnered Ghana Meteorological Agency to co-produce weather forecasts that were easy for users to understand and then use. We also developed the nowcasting product, which we usually call, that is forecasting within few hours, that's 0 to 6. So today you see Ghana Meteorological Agency doing impact forecast, trying to provide forecasts for the fishing industry, for farmers, for all others. What we did was unique. We brought all these stakeholders, and then they help us as scientists to demystify what we are doing, to let them see the climate indicators, how the forecast should be presented. What, therefore, we do finally was to provide the forecasting to have tabular description, rather from tabular distribution to visualized forms that allow us to provide climate risk indicators for them. Now, the co-production allow, therefore, for an impact-based, user-tailored forecast for the energy sector, because we have people from aviation, now from NADMO, for fisher folks, and then for farmers. We were able to make this impact through GC African Swift, that is Global Challenge Research Fund for Science for Weather Information. And this project, I served as the co-PI and also a work package lead. Prof Chair, ladies and gentlemen, I present weather forecast for the next 24 hours by courtesy of KNUST Forecasters Web. Now we currently have our students providing this forecast information. This is through this story that we decide to student. So I forecast. Now you can see the day temperature is supposed to be 29. The night we are expecting 24 degrees Celsius. And then we also expect that we have only 5% chance of rain. But the humidity is about 85% in the night. So in the night, if there should be rain, then it's likely. However, remember that we currently have very high level clouds. We call the Saros clouds, layer clouds. That is why sunlight is not penetrating, and so we have very cold weather as we are experiencing. But remember that this can have only slight showers. If we produce a rain, we call that rain vigors. These vigors will evaporate in the atmosphere, and that is one challenge that we face in rainfall. Thank you. That is my weather forecast. Prof Chair, ladies and gentlemen, developing the next generation of coal crackers is vital for sustainable development of our country and the world at large. For the past 15 years, I have worked diligently on capacity building initiatives, focusing on training skilled workforce, as investing in climate coal crackers will build a critical mass for enhancing institutional capacity in climate science. A primary example of such initiative is the Tropical Meteorology and Climate Science International Summer School, which I led to organize in 2010 and 2019 in KNUST. I am currently in a process of even organizing one this year. We are still going through the process. Adopting an integrated approach, the school brought together students and researchers worldwide. For over 2 weeks, they engaged in lectures, hands-on weather forecasting, climate modeling, related field activities. Prof Chair, I have also collaborated with institutions such as Ghana Meteorological Agency, National Disaster Management Organization, Ghana Lands Use and Spatial Planning Authority, aviation institutions in the region, NGOs, among others, to provide training support for their staff on climate hazard and risk management. I was involved in developing training manuals and workshop seminars, improve their capacity in climate data analysis, interpretation, and communication. Besides, I have worked with several WASCA research centers across West Africa, and all my projects, funded projects, I always ensure that I have funded components for PhD students, contributing immensely to developing future climate change code crackers. Prof Chair, I am thrilled to highlight the impact of my global mentee network as we did a feedback, try to do feedback from the students. We are able to generate where all of them are staying. This is shown on this slide. So you see that most of them are within Sub-Saharan Africa, my global mentees network, which include many of the former students form critical mass of climate change co-crackers. My mentees are strongly represented in various sectors of the economy as shown. They are working in academia, some are lecturers, not only in KNUST. Now we see that we have a meteorology and climate science department in UNEL. All the go there, all the students, the product there are my products. We have research scientists, postdoctoral fellows. Some are in the US. We are even exporting. Some are in US and some are in London, among others. And some are working in Ghana Meteorological Agency. Currently, all the young staffs are our students. Other related agencies as data scientists, NGO, the media, and some are even found working in the communications industry. Prof, Chair, throughout my career, I have been privileged to foster global partnerships that have significantly advanced my work in sustainable development. My research collaboration have spanned continents, including fruitful partnership with scholars from my home country, Ghana, some African countries, and extensive collaboration from colleagues elsewhere, in particular in Europe. These relationships are more than just professional partnership. They embodied my commitment to global dialogue and cooperation in sustainable development. The accompanying map visually represents these international reach, which with darker shades of green signify countries where I have more co-authors. It is noteworthy to see Germany as the leading contributor to the collaboration network, reflecting my rich exchanges with many esteemed German colleagues. My collaboration have enriched my career, reinforcing the global impact of my research and the fundamental belief that addressing climate change and sustainability challenges required a unified international effort. Prof. Chair, I am happy to share with you that my research output has substantially impacted federal academia, as shown in the worldwide reach of my citation on this slide. Also, my research output covers several SDGs, from improving climate action, that is the majority in partnership, providing hunger solutions, alleviating poverty, promoting health and well-being, enhancing clean water access, to innovating in industry and infrastructure, and effective partnership. This comprehensive engagement with the SDG reflects my commitment to utilizing research as a powerful tool for driving societal change and working towards more sustainable development and inclusive future. Prof. Chair, ladies and gentlemen, what is the future of the climate change revolution in Sub-Saharan Africa? It is crucial to prioritize climate change adaptation and mitigation for sustainable development, such as engaging in climate-smart agriculture, rainwater harvesting. People now currently, our focus has been underground water. It's good, but the rain that is coming, we have to harvest that. That is called, Ghana Water has to find a means to explore that technology. And now that we have challenge with our rivers all over, improving land management practices, doing this will contribute to improving livelihood and help minimize crime and maintain peace in the region. Prof. Chair, permit me to introduce you to two projects which I am currently leading as PI in KNUST. These projects are Concept and Furry Flood and Awaska RAF 2. The primary objective of Concept is to provide an emission inventory for greenhouse gases such as carbon dioxide, methane, and nitrous oxide, while providing information on soil moisture and nutrients and soil carbon and the responsible land management practices towards improving food security. The Concept project uses cosmic ray technology to measure soil moisture. Prof. Chair, it will interest you to know that this is the first time this technology is used to measure soil moisture in our region. It does this as erected at a point, is able to take measurement up to 300 meters. So you have a point here, and 300 meters, you imagine the speed that Usain Bolt from it will go 3 times. 3 of that times. That is the radius of the measurement point. It means that this measurement will provide a good variable point for validating satellites and then also for getting soil moisture information for agriculture. Ultimate goal of CONSET, therefore, is to contribute to greenhouse emission inventory to enhance policy direction for ECOWAS region. Fure Flood, on the other hand, is a project on the current and future quantification of extreme rainfall and flood risks in West Africa. It focuses on rural and urban flooding to underpin science-based decision-making. This research team of Fure Flood includes climate scientists, civil engineers, and social scientists. Fure Flood extends also the Siwa Rain Gauge network across the Ashanti region. This will allow us to provide flood risk map covering selected administrative districts in the Ashanti region that include KMA. Prof. Chair, we all have a role to play in this revolution. To highlight a few by designation. Vector-borne disease model should be used to support malaria control in the country. I therefore recommend VETRI to the National Malaria Control Program to improve their malaria disease surveillance and control. Ladies and gentlemen, the Ghana Meteorological Agency has pivotal role despite their work in providing observational network for weather monitoring across the country. There's still the need to improve the density of the existing network. Some of the networks, some of the stations are even not currently had challenge. Therefore, government must adequately equip and empower Ghana Meteorological Agency to expand its observational network. This will enable them to proactively collect, interpret, and archive reliable climate data for climate impact studies and early warning operations. Prof. Chair, I wish to acknowledge the long-standing memorandum of understanding between KNUST and Ghana Meteorological Agency that has helped us advance meteorology and climate science education and research and play an integral part in continuing the revolution of cracking the climate change code in Ghana. In this regard, I request the Director General of Ghana Meteorological Agency to continue fostering enabling environment that promotes robust institutional collaborations and facilitates the exchange of experts and resources in KNUST and related institutions. So far, they have been exchanged. There are times that we go there and work. We put students, our students go on internship. We also send even postgraduate PhD students to go and then do. We even set up the game seamlessly. We do measurement, we do observation in terms of monitoring the weather, and then so we have the satellite dish we have in KNUST. We ensure that we seamlessly have the same at that place so that we can collectively monitor. We want to continue this engagement. Prof. Chair, Ghana National Disaster Management Organization and Environmental Protection Agencies have pivotal role in mitigating the impact of climate change. I urge NADMO to prioritize climate resilience in disaster management strategies and improve collaboration with Ghana Meteorological Agency for preparedness and response. Additionally, I encourage the Environmental Protection Agency to collaborate with the universities to enhance emission inventory data collection, which is crucial for carbon trading and finance. We can make money from that. Carbon trading and carbon finance. We can make money. We might not necessarily have, this can also be a good source for us. Collaborating among all stakeholders is essential for achieving resilience and sustainable future for the nation. Furthermore, there is the need for augmenting the National Climate Change Working Group with physical climate scientists from the academia and operational institutions to support government efforts on climate change mitigation adaptation, thus building national resilience. Prof. Chair, we in academia are committed to nurturing and expanding the generation of climate champions who will actively work to reshape the narrative and conduct research that prepared us for impending climate disaster. Furthermore, we are witnessing the emergence of new era the artificial intelligence, AI. AI holds a great potential to improve precision in weather forecasting and also climate prediction. Academia should therefore pursue AI climate-driven research. Another emerging area in research is the green hydrogen energy that will minimize emission for sustainable future. Today's circumstances underscore the profound realities no one is immune from the impact of climate change, including the media. The realization should ignite the sense of agency within all media houses, inspiring the establishment of dedicated climate desks. These specialized units will serve two essential functions. Firstly, it will continue to engage with climate experts who will educate the general public about the realities of climate change and its impact. Secondly, they will provide practical advice on how individuals can reduce their climate footprints and offer guidance on climate adaptation and mitigation options. The media, therefore, has a crucial role in equipping us with climate change. Now, to all of us seated here, you think you are exempted. You are not exempted. You are also taking yours, but yours is going to be an assignment that I will take from you tomorrow. You submit. Yeah. So my assignment questions go this way. Who is a climate refugee? How does weather affect malaria transmission? How are you helping to minimize human-induced climate change? How can precise climate information improve your daily life? Prof. Chair, ladies and gentlemen, as I bring my lecture to a close, I know you are all wondering, where is the crack code? Let me show you the crack code. That is magic with 3 C's. Where MA is the malaria is climate-driven, IC is information on climate change is important, CC is climate change mitigation, adaptation, is the way forward. Prof. Chair, ladies and gentlemen, I welcome you to join me. Let us together crack the climate change code and participate in the climate change revolution in Sub-Saharan Africa. Remember, it is magic with 3 C's. Thank you.